Dear students, in the last video we have discussed about effective slenderness ratio. Table 3 of IS 800-2007 gives maximum values of effective slenderness ratios. Now let us move to the next topic, that is types of failures. A tension member may fail in any of the following modes, that is, first one is gross section yielding, second one net section rupture or fracture, and the third one is block shear failure. Therefore, the typical design problem is to select a member with sufficient cross-sectional area to take care of these things. First, let us take the first type of failure, cross-section yielding. It is denoted by TDG. Steel members without bolt holes can sustain loads up to the ultimate load without failure. However, the member will elongate considerably at this load and hence make the structure unserviceable. Usually this elongation is nearly 10 to 15% of its original length. Hence, the design strength TDG is limited by the yielding of gross cross-section. Tensile yielding is considered away from the connections in the mid part of the member. Next type of failure is net section rupture. It is denoted by TDN. This occurs when the tension member is connected to the main or other members by bolts. Bolt holes will reduce the cross section and hence net area will govern the failure in this case. Bolt holes in members cause stress concentration at service loads. The tensile stress adjacent to a hole will be about 2 to 3 times the average stress on the net area. Actually, multiple failure paths exist. Each valid path must be investigated to select minimum effective net area to compute TDN. And the next type of failure is block shear failure. It is denoted by TDB. Actually, this type of failure is characterized by tearing out of a segment or block of material at the end of a member for certain connection configurations. This block shear occurs when a block of the member is torn out. Block shear is characterized by a failure that includes both tension and shear failure planes. Usually, this tension failure plane is normal to the force and shear failure plane is parallel to the force. Here in this slide, we will study the shear failure plane and tension failure plane. Here in this first figure, two plates are connected using bolts, and this is the direction of force applied. Here, shear failure occurs along the plane 1 to 2 and 3 to 4, whereas the tension failure occurs along 2 to 3. In the second figure, an angle section is connected to a gusset plate using bolts. In this case, shear failure occurs along 1 to 2 and the tension failure is along the plane 2 to 3. Usually, many factors will affect the strength of tension member, like bolt holes, net area of cross section, effect of bearing stress, length of shear lag, geometry of the section, ductility of the section, spacing of fasteners, and the method of fabrications. All these will affect the strength of tension members. Now, let us study about some of the members used in the design of tension member. First one is lug angle. It is a short length of angle section and it is attached to the main tension member at the connecting end. Here in this figure you can see the lug angle. Actually, to make the connection at joints, a certain length of the tension member and that of the gusset plate is utilized. If the load is heavy and the number of bolts or length of the weld required for making the connection are large, the size of the gusset plate required may be uneconomical and the structure will not look good. So, as an alternative to this, an additional angle is used along with the tension member to reduce the length of the joint and consequently the size of the gusset plate. Such an angle is called as lug angle. Here, this angle section is connected to gusset plate. Because of the load, to reduce the length or size of the gusset plate, lug angle is provided. It is connected to the main angle and gusset plate. Second type of member is splices. Here you can see the different types of splices used to connect different members. Usually these splices in tension member are used to join two sections when a joint is to be provided, that is, these replace the member at the joint where it is cut. When a splice occurs in an angle section, channel section, T section, the force is received from the member through the connection on one side of the joint and is transferred to the splice cover plate or angle section. The force is then carried through these covers across the joint and is transferred to the other portion of the member through the connection. Here in this figure you can see how that splices are used to connect different members. And the next type of member is gusset plate. Here in this figure you can see the plate. This is known as gusset plate. Here also this is known as gusset plate. Actually, a gusset plate is a plate provided to make connections at the place where more than one member is to be jointed. Example, joints of truss girder, etc. The line of action of truss members meeting at a joint are assumed to coincide. The size and shape of this gusset plate is usually decided from the direction of the members meeting at joint. The plate outlines are fixed so as to meet the specification of edge distance for the bolts used to connect the various members meeting at the joint.